So we have these things called special trig limits, and these are ratios that come up kind of frequently, especially in AP calculus, that are just kind of limit values that you need to know. So we've already kind of looked at the first one if you've watched a previous video, but this one, the limit as x approaches 0 of sine of x over x, that's going to equal 0, right? And if we're not sure of that, oh, I'm sorry, that's not true. Got my head confused. Right, so we're approaching 0, so we want to know what that is. So if we plug in 0, we know that the sine of 0 is 0, and we know that if we plug it into the bottom, that x is also going to be 0. So we get 0 over 0 in indeterminate form. So let's actually look at the graph to see what this is going to equal. Right, so we have y equals the sine of x, right, and we're going to divide that by x. So as we approach 0, so let's zoom in a little bit, get a little darker, right, as we zoom in, we can see that the function value is actually 1. Now, if I scroll in far enough, we might be able to see that there is a gap there, right? There is a hole there. You just can't see it, right? If I keep scrolling it up, it won't let me scroll in any further. But we can see that it's going through 1, that it's approaching that value from both sides. Right, so the limit of this as x goes to 0 of sine of x over x is going to equal 1, an important value to recognize. So the other one that we definitely want to know is the limit as x approaches 0 of 1 minus cosine of x over x. Now the cosine of 0 is 1, so the top becomes 1 minus 1 or 0, again over 0, indeterminate form. But if we look at this function, 1 minus the cosine of x, right? Zoom out a little bit so you can see the whole thing, right? As we zoom in, right, there is again a hole at 0, right? Desmos just can't show it because it doesn't have the capacity to, but it's going through 0. The limit of that is 0. So these are important to know because if, excuse me, if you look at a problem and think that you can manipulate it into looking like one of these, you can actually kind of jump to the answer a little faster because these are known limits and these are things that you are expected to recognize and know if you're going to take the AP exam. So right here, one important thing to note is that the x that's inside the argument of the sine function is equivalent to the x in the bottom, right? They match each other. Same thing with the cosine special trig limit. So in number 3, what happens if they no longer match? If they still match, but they have a 5 in front of them now. So is the limit now equal to 5 or 1/5, or is it still 1? So let's go back to Desmos and look at that. So again, we're going to cancel out this top. I've got, let's see, sine of 5x now in the top. And we have 5 in the bottom. So I'm going to scroll out so we can see that the function still goes through 1. The limit is still 1. So what we can see from that example is that, whoops, still on my highlighter, right, as long as these two things match, the limit value overall is still going to be 1. And you can kind of think of it because the ratio of the argument inside the sine function and the argument in the bottom, the 5x, right, they cancel out and they equal 1. You can kind of think of it that way to help you remember it. So in number 4, all we did is change the order of the fraction, right? We took the reciprocal of the original fraction. So we want to be careful, right? So we can kind of think as this as being really taking the limit as x approaches 0 of 1 minus cosine of x over x, all raised to the negative first power, right? All that's telling us is to flip the fraction upside down. So we can use our limit properties here to say, okay, well that's really, we can put the limit on the inside and put that negative 1 exponent on the outside. So we know that the limit as x approaches 0 of 1 minus cosine of x all over x is equal to 0. Whoops, that was a bad negative 1 exponent, right? And if you take the reciprocal of 0, right, you get 1 over 0, which is undefined. So this limit here actually does not exist, right? So The sine function 1, you can flip upside down because it's a 1. If you take the reciprocal of 1, you still get 1. But with the cosine special trig limit, the 1 minus cosine of x has to be in the numerator, otherwise it's undefined. And then the last thing I just want to point out with these that sometimes happen is, well, what happens if the argument inside the sine no longer matches the argument in the bottom? So what we're going to do is we're going to do a little bit of algebraic manipulation here to make them match. So what we want to happen in the bottom is that we want a 6x. So what I'm going to do here is I'm going to multiply the numerator and denominator of my fraction by 6, right? As long as I multiply into the top and bottom by the same thing, I'm not changing the value of anything. So now this is going to equal the limit as x approaches 0 of 6 times the sine of 6x. And instead of multiplying 6 by 7, I'm going to do this. I'm going to have 7 times 6x, right? They're the same things, and multiplication is commutative, so I can switch the order of things around in the denominator. Okay, well, I know with my limit properties that I can pull constants out to the front. So what I'm going to do is I'm going to take this constant of 6/7 out to the front. And that's going to leave me with sine of 6x over 6x. So now, because these things match, we know the limit of that is going to be 1. So we're going to get 6 over 7 times 1, which is just 6 over 7. So that's one way to handle how to figure out what the limit is. The shortcut is, of course, to look at, well, you have a 6x in the top and a 7x in the bottom.